All right, this video is a review for Chapter 7 for Calculus to help you prepare for my test. So this first question says, find the volume of the solid revolving about y equals 2 for y equals square root of x, y equals 2, and x equals 0. What type of a question is this? This is, right, volume revolving, and it is a white girl. So I would underline volume revolving. And because it says around y equals 2, it is a white girl. Okay. And what else do I know about y equals 2? Nice. It's my C. It's what I'm revolving around. Okay. So let's start analyzing this graph, and then we also have to take into account what our A and our B are. Okay. So what is a graph of square root of x? Good, like a teapot. Okay. And how about y equals 2? Right, just a line at 2. And then x equals 0? Just this axis right here. So we can see this like strange little triangular shape that gets enclosed. And then that is going to revolve around y equals 2. Okay. So one thing that we've noticed so far, and we've talked about in our previous videos, is that when our c and one of our functions are the same, what's going to happen in my big equation? That whole second part is going to end up disappearing. Okay. So I am going from A. A is pretty easy to see. Who is my A? 0. I need to do 2 seconds really quick, some work to find out what this B is. Okay. So I need to have y equals square root of x and y equals 2 set equal to each other. So 2 equals square root of x. What does x give me? X is 4. Good. So now I see my A to B. All right. So far in my integration, remember volume is pi times the integral from A to B, which in this case is 0 to 4. And then I have of C, C is 2, minus the function furthest from my line of rotation. So remember, you put your pencil in between A and B on your line of rotation, and you draw towards your function. And you can see I only have one function there, which is square root of x. Okay, so my formula is the C line of rotation minus the furthest function squared. Now, if you were to keep going, you do not technically have to keep going because that is the only function I see here. But if you did keep going, you'd say C, my line of rotation, minus my smaller function, my function that's closer. And you'll see that that second part cleans out. And because this is a white girl question, the easy version, everything is in terms of x. We have dx, and my a and b are x values. Okay? All right, so this next part shouldn't be too bad. We have pi times the integral from 0 to 4. I have to FOIL this here. So I'm going to say 2 minus square root of x times 2 minus square root of x. All right, are we good up to there? So next we go ahead and do our antiderivative. Okay, I end up with 4x. And now here I'm going to add 1 to the exponent, which gives me a 3 over 2. And to that 4, I'm going to divide by 3 over 2, which is by multiplying by the reciprocal, which is 2 over 3. Okay? And then plus, this will be half x squared. Don't forget to bring down that pi. So I can say that my volume is equal to pi times 4 times 4 minus, I'm going to call this an 8 over 3, 4 raised to 3 over 2, plus half, that 4 goes there, minus, you don't have to write this part, but I like to write it just to make sure I don't skip it in case it is another number. The 0 into everything would give me 0. And I am done. That is my FRQ answer. All right, this next question says, find the volume of the solid whose base is bounded by y equals square root of 25 minus x squared and the x-axis with cross sections that are squares. So I see the word volume and I see the word cross sections. Okay? The base is going to be bounded by these two functions, and the specific cross section that I want are squares. Okay? So for starters, what is my formula going to be if the cross sections are squares? The integral from a to b of top function minus bottom function squared. Very nice. Dx. These are pretty easy as long as you remember the formulas. Okay? Now, if I draw you a graph, who remembers what the function of y equals square root of 25 minus x squared is? If I have an x squared and a square root. Okay, anytime you guys see a square root and a squared inside of it, it is a semicircle. Let me show you why. Okay? Let me get a different color. If I say y equals square root of 25 minus x squared, how would I get rid of that square root? I would square both sides. Okay? So then I would have y squared equals 25 minus x squared. Move that x squared over. I have x squared plus y squared equals 25. This right here is an equation of a circle with a radius of 5. Remember square root of that number. Okay? So now work our way backwards. Usually when I apply the square root, I have to put a plus or minus. This one only had the plus, not the plus or minus, which is why it is a semicircle. It is just the positive portion of that circle. So the positive portion of that circle would be the top half. Okay? So my graph goes, oops, let's pretend all of these lines are matching up. Okay? It should hit the 5s. I apologize for my drawing. So that is my base. Now it says my function is bounded between that semicircle and the x-axis. Okay? So what I'm really working with is this space in here. So who is my f and who is my g? F is the square root of 25 minus x squared minus g is 0, which makes life really easy. And then the formula has a squared. Who is my a to b? Negative 5 to 5. So if you don't feel confident with that equation and graphing, know that you can still find a and b by setting your two equations equal to each other. So I would say that 0 equals the square root of 25 minus x squared. I would have to square both sides to get rid of that radical. And then I can say that 0 equals 25 minus x squared. Move the x squared over. And then square root of 25 is plus or minus 5. So that's how you can still get your A's and B's, even if you didn't know that image, okay? All right, so this minus 0 is irrelevant. What happens when I square that square root? Cancels. So I'm really working with the integral from negative 5 to 5 of 25 minus x squared. Okay, again, that's squared, and this square root cancels there. Antiderivative. Okay. And now we can say that the volume is the function at B minus the function at A. And that would be an acceptable answer for a free response. You do not have to clean it to the end. All right, this next question says, find the area of the region bounded by f of x and g of x. So what is the highest exponent in f of x? X squared, which means a what? What kind of shape? A parabola. And what is the y-intercept for this parabola? 225. Okay, look at g. What type of a shape is this? What's the highest exponent? Linear. And what's his y-intercept? 255. So who's top and who's bottom? Nice. So we didn't have to draw, and you figured out who top was and who bottom was. Okay? I will still draw so you have an idea. Okay? So let's say this is 225. And then let's say this was 255. So I need to find out point A, and I need to find out point B and what those are. How do I find out what A and B are? Right, equal the two functions to each other. So I have to say that x squared plus 30x plus 225 equals 17x plus 255. So next you're going to have to move everything to one side. We good up to there? Now factor. So you can find your two x's. Two numbers that multiply to give me 30 but combine to give me 13. 15 and 2. If my middle term needs to be positive, who needs to be positive here? The 15. So I have that x equals 2 and negative 15. Okay? So now we go to our integral. We can clearly see who's top and who's bottom here. We have the integral from a to b, from negative 15 to 2 of top minus bottom. Bless you. Oops, I made a mistake. I wrote 225 over here. Sorry, guys, I'm fixing this number, okay? And it's a little hard to see, but I had to slide in a little dx there, okay? All right, next I need to distribute this negative and then combine like terms. Take a moment and do that. And I'm going to write them in order, from the highest exponent to the smallest. All right. Our next step is to do the antiderivative. And our last step, we could say that the area equals, okay, this is a little lengthy, so actually I'm going to take it down here just so that it all fits. So my function at b minus my function at a. All right, and that bottom row is your answer. All right, for our last question on this video, it says find the area of the region bounded by f of x and g of x. Now, I'm going to start off by finding a and b this time, okay? So, I'm going to set the cube root of x minus 1 equal to x minus 1. I always want to try and get rid of the roots. So, in order to get rid of that cube root, I need to cube both sides, okay? So, I have an x minus 1 here. And then on this side, I have 3x minus 1s. Okay? Now, you have two options. You can FOIL out that right side completely, move everything to one side, and start solving for x's. Or if you catch that 1x minus 1 is on both sides, I can cancel it out. But if you literally cancel it and ignore it, you will be missing one of the zeros. So if I do FOIL this out and combine like terms, what's my highest exponent going to be? 3 cubed, right? Remember that the highest exponent also tells me how many zeros I'll have. Okay? So if you find that you can cancel out one of them, the one that you cancel out also happens to be one of your zeros. So, because we canceled x minus 1, you also have to set that equal to 0, and that gives me x equals 1. That is one of my answers. Now, I can continue with what was left over here. When this cancels out, what am I left with on this left side? What is x minus 1 divided by x minus 1? 1. Equals, and then on the right side, I just have to FOIL these two, which would be x squared minus x plus 1. Are we clear on this rule that if you cancel something out, it will also be one of your zeros? You can't just completely forget about it, okay? So now I'm going to move everything to one side and combine like terms. Okay, those ones end up canceling out. The two negative x's become a negative 2x. Now here I can factor out an x. And I get that x equals 0. And it equals 2. So that means that I have 3 zeros. Okay, this is one of those scenarios where I will have two sections. Okay, so if I were to start analyzing my graph, and the more you know about graphing, the easier this is going to be to understand, okay? I know that my A, B, and C, A is going to be 0, B is going to be 1, and technically C is going to be 2, okay? Now, the graph of x minus 1 is just a linear function that went down 1, okay? So, it has a y-intercept of -1. And it has a rise over run of 1, and it's going to go straight through. Okay? Now, cube root, in my class, if we've done the dance moves, it's the walk like an Egyptian. It goes over on the right and under on the left, and that -1 on the inside means that it moved 1 to the right. So it goes over on the right, and now you can see that point of intersection, and it goes under on the left, and you can see those 3 points of intersection. Okay? So my cube root is my f function, so we can clearly see who's on top and who's on bottom on each point. And my linear function is my g function. Okay? Now for our setup, area is the integral from a to b of top minus bottom. So if you look here, I'm first going to go from 0 to 1. And we can see that my top is g, okay, which is x minus 1, minus my bottom, which is cube root of x minus 1. Okay? Now plus the second portion, the integral from 1 to 2. My top is f minus my bottom portion is g. Okay? Now I'm just going to do a little distributing. Distributing on this one, there's not much to do. I can drop those parentheses. Here I do have 2 terms that I can distribute to. And now it just looks a little cleaner. So when I go to do the antiderivative here, the term of x and the term of 1, whether it's positive and negative, is going to be nice and easy. I am going to have a mini u sub to do in here, okay? The good thing about this u sub is nothing's going to be missing. So let me show you why. If I claim that my u is the inside, x minus 1, then my u prime is just 1, which is fine because I do have a 1 as a coefficient. So if nothing is missing, I can treat this portion as the integral of u to the 1/3, which what is the antiderivative there? 4 over 3 is my new exponent, and my coefficient is 3 over 4. So when I go to do the antiderivative of this portion, this will be my answer. Okay? And the same will go for this guy. Okay? So now let's move on. Antiderivative of x of 1. I can bring this guy down. Now there is a minus there. 3 over 4. I'm going to plug my u back in. X minus 1 to the 4 over 3. This one goes from 0 to 1. Plus, my first one is the same as this one. 3 over 4, plug my u back in. And then minus half x squared. And plus x. And this one goes from 1 to 2. Let's scoot over a little bit. Last part is our f of b minus f of a. So I'm going to do the first one, and then I'm going to say plus the second one. So I have the first function at 1 minus that first function at 0 will all cancel out. Plus, now the f of b minus f of a, the second one. This one's going to be a little lengthier because none of those two numbers are 0. All right, and this whole bottom portion would be considered your answer for the FRQ. All of this here, okay, guys? So I just had a student correct me on a mistake. Check this out. We cannot assume that this next term equals 0 because when you plug 0 into x minus 1 is negative 1, it does not cancel this term out. So I'm going to white out this second portion. Okay. And now I have... Now, if you don't write these two, it'll still be okay. I'm going to write it just so that we go through the motions. But very good eye. All right, now that is a final answer. The top one, f of b minus f of a, plus the bottom. If you chose to skip out on writing this term, it's okay because 1 minus 1 is 0. If you chose to skip out on writing these two terms, it is okay because they cancel out. And lastly, this one because 1 minus 1 is 0. If you skipped out on writing those four terms, you would still be 100% correct. Okay?